So what is nomenclature? Nomenclature is the way most compounds are named based on the rules they follow. However, some compounds like water have their own common names. There are three main categories when it comes to nomenclature. The first one includes the ionic non-acid compounds. These compounds are made of cations and anions. The positive and the negative ions are held together by the electromagnetic force, which is described by Coulomb's law. Within this category, we have some subcategories, which include type 1, type 2, and the polyatomic non-acid ionic compounds. By the way, this example here is something that you're all familiar with, which is sodium chloride. In the real world, that would be table salt. The next category includes the covalent, also known as molecular non-acid compounds. And these compounds are formed when atoms share electrons. For example, here we have nitrogen monoxide, and they are sharing electrons. Our subcategory includes type 3, and type 3 consists of two nonmetals, such as this compound that we have here. Nitrogen and oxygen, they're both nonmetals. Our third category includes the acids. And acids are basically substances that donate protons, or we can also say hydrogen ions, to another substance. In the lecture videos that I will be presenting, we will be working with binary acids along with the 9 common polyatomic acids, which, by the way, they have their own naming rules. So, as mentioned, acids are substances that donate a hydrogen or a proton. For example, in this chemical equation, we see hydrochloric acid donating a hydrogen ion to the compound of water. And the product is that we get hydronium and chloride. So before we learn the individual rules of nomenclature, let's first look at the overall structure of our nomenclature system. I want you to think of this slide as our roadmap for naming compounds. Let's begin with the start box. First, we name the first element or polyatomic ion. Then we name the second element or polyatomic ion. And if it's an element, we change its ending to IDE. From the start box, the main pathway divides non-acid compounds into 3 categories. And those 3 non-acids to begin with are seen here in the top: type 1, type 2, and type 3. Type 1 consists of ionic compounds. Remember, an ionic compound consists of a cation plus an anion. And the cation is going to have a fixed charge. And that fixed charge metal can derive from column 1, column 2, or what I call the 6-pack. The fixed charge can also be ammonium. So basically what makes type 1 different from the rest is that it has a fixed charge. Type 2 consists of ionic compounds whose cation can have different possible charges. Because the metal can have more than one charge, a Roman numeral is used to indicate the charge of the metal in the compound. So these are the Roman numerals that we use. And the metals and the two metalloids that we're going to be working with in an introductory chemistry class are going to be the ones highlighted in blue. For the simplicity purpose, the ones considered in an intro class are going to be these ones shown in blue. Type 3 consists of covalent, or also known as molecular compounds, made from two nonmetals. And these compounds are named using prefixes, as you see here on the right side. Like I said, these compounds are named using prefixes to indicate the number of atoms of each element. The star box also branches downward to binary acids. These compounds are handled differently from the non-acid compounds. When a binary compound that forms an acid is dissolved in water, it is named as an acid using the binary acid naming rule, which is seen here. So the rule is that you write hydro, then the root name of the nonmetal, the suffix ic, and the word acid. Some examples include hydrofluoric acid, hydrochloric acid, and the rest that you see here. Sources for naming the second part of the compound are seen in this box. So, in the center of the slide, which is what we're seeing right now, we have the sources for naming the second part of the compound section. The name of the second part can come from one of the three sources. They can come from the 9 common polyatomic acids, which must be memorized to derive their corresponding polyatomic anions. So basically what I'm telling you is, remember these 9 common polyatomic acids, and from there you're going to be able to derive their anions. Another source for naming the second part of the compound includes the common non-metal anion charges, which are used to derive the IDE names. So remember these nonmetals so that way you can know their anions whenever you have to name specific types of compounds. And the last box that works as a source for naming the second part of the compound is what I call the memory polyatomic ions, which are these ones here seen in this first column. All three boxes are the sources for naming the second part of the compound that you need to name. Moving on, we have the polyatomic non-acid ionic compounds, and these compounds are named using either the type 1 or type 2 rules that we saw in the beginning. And there are 7 different variations. Finally, we have the common naming exceptions. These are substances or ions that have names we need to recognize rather than derive from the normal naming rules. And examples of those include water, hydroxide, ammonia, and ammonium.